Today, PRAESENSA power design. We will show you what the basic power design is for PRAESENSA, and also how you do a design when you have a little bit larger system. So the topics for today, we start with components and symbols. So the components that we have to power, the components that provide us power, the symbols that we use for it in drawings, and then we will do some designs for a small and a larger system, and a remote system where you have also components on a remote location. At the end of the presentation, you can ask, or we will try to answer your questions. Yeah, focus for today is power design. So we will not talk about network design. That is a separate webinar for that. So we don't discuss power consumption or battery size, because we have a power calculator tool for that, where we also have another webinar about. Yeah, so when we do a design for power, at least for today, we don't show batteries and we don't show network connections. It's important to realize we'll only focus on the power connection. Yeah. I've mentioned the program already. We look at the components, symbols, and then we do some examples of how to power a system. Yeah, starting with components and symbols. Yeah, the controller. You probably know that if you've done the online training, or perhaps even the classroom training. Yeah, this is the rear where we have the power connection, and the first thing that you see with the system controller is that you can power it from 24 to 48 volts. So you have a wide range of power supplies that you can use there. The symbols that we use, Visio symbols, also have those power connections. That's the orange connection over there. The blue ones are the network connections. And if you look at the specification of the controller, you already see we have 24 to 48 volts. The power consumption is almost 6 watts, but what you immediately see, depending on the voltage that you apply to what you use for powering, the current is different. So 0.25 amps for 24 volt and 0.13 amps for 48 volt. Those are things that you have to take in account when you select the power supply. We go to the amplifier, the 4 and the 8 channel amplifier. You see the rear is a bit different, but the power connections are exactly the same. Yeah, so you have two connections, 2 times 48 volts. So this doesn't have a range of 24 to 48 volt, just 48 volt DC. The symbols that we have for the amplifier are these symbols. So this is the 4 channel amplifier and the 8 channel amplifier. The connections for power are the same. Also, the network connections are the same. And what you also see here on the right side is where we have 3 amplifiers powered from an MPS. We'll talk about the MPS in a moment, but an MPS can power 3 amplifiers. And this is what we call a cluster. Yeah, the yellow connections here are the power connections. So this is a bit, brownish. Yeah. But the combination of an MPS and 3 amplifiers, that's what we call a cluster. And that cluster, that name, is also used in our power calculator. So let's have a look at the specification for power, 48 volt. And then there are some slight differences in the 4 and the 8 channel amplifier. We have a snooze mode when the amplifier is, let's say, idle and doing actually nothing. But what is important for the power calculation is the maximum power consumption. Yeah. So the rated power for this for the 4 channel is amplifier is 220 watt, and for the 8 channel is a little bit more, 244 watt, 42 watt. But what you also see is that the current consumption is already a little bit lower for the 4 channel, and 5.1 a little bit higher for the 8 channel. And that is the current consumption at maximum power. So when we deliver almost 220, 240 watt to the load connected to the amplifier. Then we have the MPS, the multifunction power supply. Connections on the rear. Connections for the system controller, 2 times 24 volts. So we power the controller from the MPS with 24 volt DC. Then we have 3 connections for amplifier, double connections, 2 times 48 volt. The network connections, we have 5 Ethernet ports, but the first 2, they have power over Ethernet, PoE. And you see that little flash symbol over there, just above the RJ45 connector. Symbols for the MPS, 3 versions. Well, we have different positions actually. And then you see the connections for power. Yeah, so this is for the controller, this is for the amplifier. The different colors you see, orange and a bit brownish. The power over Ethernet, the blue connections with that little flash symbol. And you select one of those symbols here, depending on how your design, how the setup is of your design. You can select, you can exchange them as well. So let's have a look at the specification. The power for the controller, 24 volt, 0.7 amps, we can take from that. The amplifier, 5.5 amp. Lifeline, that is actually the power that is available on this connector. Yeah, it's 18 volt, 0.7 amp, but it is something that we actually don't use. We only use it for the lifeline and for the amplifier. Yeah, and then we have PoE, power over Ethernet, 15.4 watt available on each output. We go to the call stations. 2 call stations, the desktop and the wall mount. The only difference actually is the microphone. The rest of the call station is exactly the same. Connections for the Cat5 cable, the RJ45 connectors, that also provide the PoE, the power over Ethernet for the call stations. Yeah, the symbols for the call station you see here, and where we have the 2 blue connectors for the blue connection points for the Cat5 cable, but also the little flash symbol that is the indication for power over Ethernet. Specification, well, power over Ethernet is specified as a voltage between 37 and 57 volt DC. Power consumption is 5.4 watt for a call station, and when you have 4 extensions, the total power consumption is 9.4 watt. So that is less than what is available, of course, on the MPS. The MPS provides 15.4 watt on a network port. Yeah, so 9.4 is okay. Then we have the switch, the ES8 P2S Ethernet switch with 8 ports. Yeah, the symbols, what you see here, what we have in Visio, where you have the power connections and we have the PoE connections. Yeah, and PoE connections, where are they? Yeah, there they are. You see the power consumption of the power that you can use, 24 to 48 volt DC. Power consumption of the switch itself is not so much, 12 watt. But here you already see whether you power it from 24 or 48 volt, you see also the difference in current. Now, the switch itself takes 12 watt, and then it depends on how many ports that you use PoE. Yeah, the maximum load on a PoE, for PoE on one port, Ethernet port, is 30 watt. But the total of all ports together cannot be more than 120 watt. And the total can be not more than 120 watt. But when you take 120 watt from the Ethernet for PoE, then the power consumption of the whole switch will go up, of course. And you can see it goes up from 12 watt to 140 watt. That's quite a lot. And if you look then at the current, it's almost 3 amps and almost 6 amps at 24 volt. So be careful there. Next, then we have 2 power supplies, 24 volt, 10 amps and 48 volt 5 amps, these are not EN54 certified power supplies. These are just standard power supplies, no more than that. Yeah, symbols for the power supplies, 24 volt and the 48 volt. We have a mid-span injector. The mid-span injector will provide us power over Ethernet for Ethernet ports that have no PoE, no power over Ethernet. It works like this. You have, for instance, a switch or an Ethernet port where there is no power over Ethernet, no PoE. You connect the mid-span injector, and the mid-span injector will take care of the PoE, the power over Ethernet, for the powered device, for instance, the call station. Keep in mind, there is a limitation on the length of a Cat5 cable, and that is 100 meters. The moment you insert this PoE injector, this distance stays the same. It's not that you have 100 meters before and 100 meters behind after the mid-span injector. The overall length will remain 100 meters. It will not change. Yep. So we have two versions of that, the 5001, that's a single port, and we have the 5004, and that is the 4-port power injector. And both, on all ports, we have their 15.4 volt available. Symbols for this, PoE insert with 1 port and the PoE insert with 4 ports. And there are the connections. So on one side you have PoE, and on the other side you have no PoE. Then we have other third-party devices, and that are the analog audio to Dante converters. And in this case, these examples are from Aterotech. There are many more brands. Yeah, you see it in different shapes. You have small boxes where screw connections, but you also have wall panels with XLR and Kinch and mini jack connections there. Just what you need. Most of the time you can find it. The symbols for these panels, for these analog audio to Dante converters, you see analog audio in and Dante out. Sometimes they are PoE powered, sometimes they need an external power supply. And there are the network connections. If you look at the power consumption of a this DX4i, that is 5.6 watts. It's not so much. It's less than a call station. So this was an overview of all the components that we have. So the controller, the amplifier, MPS, 2 call stations, and an extension. And for the third-party devices, the Ethernet switch, 2 mid-span injectors, 2 power supplies, and analog to Dante audio analog to Dante converters. So let's have a look at the general power, the general power concept. Well, this is the way how we have designed the system. The MPS is the power source for the controller, 3 amplifiers, and 1 or 2 call stations. It depends on how you power the call station. Yeah, you can have a single cable going to a call station, or a dual cable, a double cable, so then you have a redundant connection. And this design will always work. Yeah, the MPS can deliver the power for the amplifiers and the controller and for the call station. That should be no problem at all. Yeah, this is what we call in the power calculator a cluster. And here you see what is available for power. Yeah, the lifeline power we actually don't use because it's already used for the lifeline. And this is what is available for the system controller, amplifier, and PoE. Yeah. Now, the moment you start changing your power concept, so you're not using the MPS anymore, or you are using MPS plus other power supplies, then you have to be able, or then you have to be careful, and you have to know how much power a device needs, and also how much power that is available. Yeah. So make sure that that part is all right. that you have enough power available for the devices that are connected. So let's have a look at an example. We have a controller, 3 amplifiers, MPS, 2 call stations and 2 extensions. This is actually what we call the cluster. Yeah, and this is the block diagram, and this is how you would connect it. So you have your 3 amplifiers connected from to the MPS and powered from the MPS. You have a double power connection to the system controller, and you have 2 call stations connected here to the Ethernet ports with PoE. So this is port 1 and port 2. But what you also see is that this is a single cable. It's not a redundant connection. Yeah. So for this design, the MPS is designed for 3 amplifiers, a system controller, and 2 network ports for PoE for call stations. So this design is okay. There's nothing wrong with this design. This is okay. This is how it is intended to be. If you wire this system, yeah, it would look like this. So you have your MPS, then you have your connections to the 3 amplifiers. So that is lifeline and power. And then we have the power for the controller. Yeah, and then we have the 2 Cat5 cables for the call station. Yeah, so this is what the wiring would look like. Second example. System controller, 6 amplifiers, MPS, 2 MPSs, 2 call stations, 2 extensions. Yeah, so we have the system controller on top, 2 MPS and the 6 amplifiers. And this is also a bit the Visio symbols are designed for. The Visio symbols are designed to have a drawing from left to right. So the call stations on the left, amplifiers on the right. And then most of the time the connections are quite easy to draw. This is how we would connect everything. So you see the MPS is powering the first 3 amplifiers. The second MPS is powering amplifier 4, 5, and 6. What we've done here for powering the system controller is that we have 1 power line from the system controller for the system controller from the MPS number 1, and another one is coming from MPS number 2. Basically, that's an extra kind of redundancy. So if this MPS would fail, then still the other one is available and can power the controller. And that is also the same for the 2 call stations. So the call station is powered from 1 MPS, and the second connection is coming from the second MPS. So we power the call stations from the first and the second MPS. So if 1 MPS would fail, yeah, you will lose, of course, the amplifiers there, but you still have the controller and the call stations powered. Yeah, so 1 MPS, this is the second MPS, and for this design, the power is okay. So there should be no problem here. And you have power redundancy for the controller and for the call stations. And in the power calculator, here you have to deal with 2 clusters. So you have 2 times an MPS and 3 amplifiers. Another example where we have more components. So we have still 1 controller, 9 amplifiers. If we want to power 9 amplifiers, we need 3 MPS, 4 call stations, desktop, 2 call stations, wall mount, and 16 extensions. So the system is growing. How to power this? Well, the first part is of course simple. You have your MPS powering 3 amplifiers, and you have that 3 times. So that's okay. Then we have the controller. It's powered from 2 MPS. From this one, number 2 and number 3. 2 call stations can be powered from this MPS number 1 with a single cable. These 2 call stations are fireman's panels could be used as fireman's panels. You want to have redundancy there. So we want to power them via 2 PoE ports. Yeah, so this is what is connected now. And you also see immediately a problem arise here, and that is these 2 call stations. There is no PoE port available anymore in the system. So if we want to have these call stations working, we need something that can provide us with extra power over Ethernet. Now, and the simplest solution is, of course, a PoE insert. Yeah, we have those, a 1 port and a 4 port PoE insert. We can use a PoE insert here, and the call stations are powered. Yeah, PoE inserts are not EN54 certified, so keep that in mind. Yeah. So if you look at the power design now, power is okay, of course, for the amplifiers, for the system controller, and for the 2 call stations there and the 2 call stations over there. Here we have PoE insert, and you just know, we know that this will work, yeah, because 15.4 watt is available. A call station takes 7.4 watt. With 4 extension, the maximum power consumption will be 9.4. So this is also a power design that is okay. Another option that you could have, what you could use, is that you don't use the PoE insert, but that you use a switch, the certified switch, the ES8P2S. And here you can connect all your call stations, yeah, to the same switch. But the switch has to be powered. Yeah, so option 1 is actually that you have a 48 volt or 24 volt power supply there. But keep in mind, the power supply is not certified. Yeah, but in this way, this would work. Yeah, so the 48 volt power supply, 5 amps is available. The switch will take 0.5 amp. For the call stations, you need a little bit more, so you go to 0.9, and this power design is okay. Yeah. So if you want to have this as a certified switch where the power supply is also certified, EN54 certified, you could consider to power it from the system controller output on the first MPS. But you have to be careful there because the power there is limited. And let's have a look here. What is available and what we need. The system controller, 24 volt out, 0.7 amps. And for the switch, that is okay. Yeah, when the switch is powered with 24 volt, it will take 0.5 amps. That is no problem at all. But the moment that you start powering call stations, the power consumption will go up, and the power consumption will go up, and the current that you take from the source is 1.75, and that is not available there. It's only 0.7. So this power design is not right. You cannot power a switch from the system controller output here when you also use PoE. And you have to be very careful. So this is not right. What is right? Well, this could be a solution if you have on the MPS a power output available for an amplifier, and the amplifier is not connected. So here you have 48 volt available, yeah. And with it 48 volt, you can power this switch, and then you have an EN54 certified power supply for the switch. Yeah. So let's have a look. MPS output 5.5 amp. MPS, the switch 0.9 amps, including the PoE is 1.9. So this is okay. More than enough power available. Yeah. Here in this design, we have 3 clusters. So this is a cluster, this is a cluster, and this is a cluster. Clusters for the power calculator. Another option or another option, another design is where you have more switches. You have more call stations in the design. You use more switches that you power from the amplifier output on the MPS, the third MPS. And what you see here, this is no problem. So powering 2 switches from an amplifier output on the MPS is okay. Yeah, 2.4 with 1 switch, 3.8, yeah, with 2 switches. But the moment that you add a third switch and you also take PoE from that switch, you'll see that the power consumption will go up to 5.7, and that is more than that is available. 5.5 is available, 5.7 is needed. So here it is critical. It is critical, it's not wrong. And why is that? Well, the power consumption for a call station, and so that is the PoE here, that is worst case power consumption. For instance, when you do an indicator test, all LEDs on the call station start blinking and the buzzer will go off. So then you have the maximum power consumption. You probably will never do that on all call stations at the same time. So 5.7 is also a worst case value. Another example number 4. Here we have the components, and what we are now doing is we are not using an MPS. We are only using power supplies, and that automatically means the system is not EN54 certified. Yeah. So for the controller we have the 24-volt switch, power supply. For the amplifiers we have the 48-volt power supplies. For the call stations and the analog audio to Dante converters, we will have this PoE insert. And that would look like this. Yeah, power from the 48-volt power supplies for the amplifiers. The 24-volt power supply is for the system controller, and the PoE insert, the 4-port, is for the call stations and the analog to Dante converters. If you look at power, the 24-volt power supply, 10 amps available, because the power consumption for the controller is very low, 0.25, no problem. For the amplifiers, the power supply, 5 amps available. Worst case power supply for the amplifier is 5.1, it's a little bit more, but the power, the 5 amp that's a continuous value. The peak value for the current of these power supplies is 7 amps, so that should be no problem for the amplifier here. Then we have the 4-port Ethernet PoE insert, 15.4 watt available per port, and we are using 6.4 and 5.6 watt for what is connected, and so this is also no problem. So the power design here is okay. Yeah, but it is a non-EN54 certified system if you power it like this. Example number 5. Here we have a system on a remote location. So the first part is the controller, MPS, 2 amplifiers and a call station. And then on the remote location, that's on the right side of the drawing, we have 2 amplifiers, a call station, 1 amplifier, an MPS, and a call station. Yeah. How do we do this? How do we connect that? Well, we have the 2 power supplies powered from the MPS. System controller is powered from the MPS. The call station is powered from the MPS. We have a glass fiber connection to the remote location. And there we have an MPS, an amplifier, and a call station. Yeah. So the MPS power, the design for 3 amplifiers and a controller. So in the central system, this is okay. This part of the design is okay. In the remote system, there's also no problem. You have one amplifier, an MPS, and a call station. This is also a good design. You could change it. You could take the MPS out on the remote location here and replace it with the switch that is powered from a power supply, and also the amplifier is powered from a power supply. This is a non-EN54 certified system, of course, because the power supplies are not certified. Yeah, in the central system, everything is okay. Yeah, MPS, 2 amplifiers and a call station and the controller. In the remote location, you have to look at the power available, 5 amps. Yeah, you need 0.39 amps for the switch, and this is what we have. This is what we need. This is what we have. The 5 amps. So this is okay. 5 amps available and 5.1 for the amplifier. Basically, that's also okay. So this power design is also okay, but the remote location is not EN54. Keep that in mind. Okay, we had some examples now for power design. Time for questions. Do we have questions?
Not yet see any questions at the moment. Yeah, please ask them in the chat box and send it to all panelists.
Is it a bit clear that you have to pay, if you have a standard configuration with an MPS and 3 amplifiers, then it is actually quite simple. But the moment you start changing something and start using power supplies instead of the MPS, then you have to be careful that you have enough power available. Yes, it's clear. Aha.
Oh, there is one. Will the power amp use 1 or 2 48 volts when using 8 channels of 600 watts?
Will the power amplifier use 1 or 2 48 volts? They will always be using two connections. Yeah, and basically one connection can power the 8-channel amplifier. Yeah, but we have 2 connections. That's for redundancy. So if one fails, the other one is still there. But basically both are used when you're connecting to an MPS. Is it still redundant? Yeah, EN50. Oh, I think that I know what you mean. If you power it from one cable, yeah, it will work, of course. But EN54 requires 2 connections for power. Yeah, so for if you want to comply to EN54, you have to use both power connections there.
Another one is then, how would you extend call stations beyond 100 meters distance?
Yeah, you can go to glass fiber. That's the simplest way, actually. Of course, on the remote site where the call station is, you have to be able to receive the glass fiber. And if it has to be EN54 certified, everything what you do, that part, that power part, also has to be EN54 certified. Yeah, and that could mean that you need an MPS there with a battery only to power the call station there.
Oh, we have another question, but I see it's addressed to the host privately. Do we have a calculation tool like Excel for power design?
Yeah, that is the power calculator. What I mentioned, we talked about, yeah, I mentioned power calculator several times, but every time that we talk about an MPS and 3 amplifiers, a controller and 2 call stations, that is what we call a cluster. And that is how the power calculator works. There is a separate webinar over the power calculator. Yolanda will tell you later, I think, about that. Yeah, and that is the tool that we use for power calculations for PRAESENSA. Any more?
And no further questions I can see.
I think also not. So Peter, I would say, please go to the next slide.
Oh, here you see it already.
Yeah, indeed. So I would just quickly like to take the opportunity and show you which are the topics for the upcoming webinars. The first one is in 2 weeks from now, and it's about indeed the PRAESENSA power calculator, how to use it, PRAESENSA power requirements, battery calculation, and a demonstration. So September 30 from 10 to 11. Then 2 weeks later, a webinar about block diagrams using Visio shapes. There you learn all about drawing stencils, importing, selecting stencils, as well as how to use symbols in a block diagram. And then end of October, we have PRAESENSA, how to set it up from scratch, and also security management. And that basically explains the story from when getting the boxes, opening the boxes, setting up connections, to factory defaults, firmware upload, accessing the system controller, and it will end with a demonstration on how to do that. Then I see we have another question. Which cable can be used for the connection between the MPS and the amplifier? Fire resistance or any other?
Well, the cables that we have for the power are supplied with the amplifier and with the MPS. So, and the MPS and the amplifiers most of the time are very close together, within 1 meter, 1.5 meters. So that's also the length of the cable. And that will also most likely be in a 19-inch cabinet. And inside that cabinet, you don't need to use fire-resistant cable. But the cables for power and also the cable for lifeline is supplied with the amplifier and the MPS. The only thing you have to do is make the connections to the connectors, and then you can use it. You can cut it at the right length, and then you can use it in the system. Okay. Another thing regarding the connections and cables, also the cables for the batteries are supplied with the MPS. So the cables are 1.2 meters length. They are 35 square millimeters, so that's a very thick cable. Also the connections are already there, so I'm not sure how you called it, the cable shoes or so are there. So basically it's only that you have to connect it to the battery, connect it to the MPS, and that's it.
Good. I think it looks like that's indeed it, and all the questions are answered.
Yeah.
That then concludes today's webinar. Thank you all for your time and attention. We hope that you will join us for the next community webinars as well. Don't forget to leave your email in the chat box if you want to receive today's presentation. We will leave the chat box open for another minute or so. And then I just want to wish you all a good day and stay safe. Thank you.